Good morning, good afternoon, good evening, YouTubers. This is Jerry Diamond with How to Get Out of Babylon and Flat Earth Homeland. And I'm doing get some light on the subject there. There you go. All right. I've set up an experiment and I'm just showing you what I've done so you can do this yourself, do a lot better job of it, whatever, however. But I've got a laser. I've got a targeting system that is on a, get the head off my headlight, get the light off my head, okay. And the little post-it note is there so I can see the laser beam. And then if you add some, let's see, let's turn the light off. So you can actually, if you get introduce some smoke into the environment. I know this from campfires, it's really awesome. You get a fire going over a valley and start shooting a laser through it. It's almost blinding, but you know, I can barely see the beam of the laser. So there, a little bit better, see. So if the box was full of smoke, and you could work that out one way or another, a smoldering something, or put light a cigarette. I'm using a cigarette, although I'm not smoking anymore, but I have a hole in the box there, but that wasn't working. It's just, I'd have to close the box off and have just a little opening for the camera. Okay, so let me show you the setup I've got. Okay, so I measured 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 inches. Okay, and then on the inside, I've measured from the bottom, and it's kind of hard to get the outside of the inside because there's about 1/8 of an inch of cardboard, obviously, so not totally exact, but I put a scale up there. 1, 2, 3, 4, 5, 6, 7, 8, up to 15. It'd be really hard to hit 15 because of the angle. Your holes would have to be cleaner than that, like drilled, and they would have to be made so that when you're, you know, aiming through that one, that you're not obstructed. Okay. Down there at the bottom, not so hard. The first several would not be very difficult, but when you get up to mid-range, you got a steeper angle, and a steeper angle yet at the top. Okay, but I'm glad I did this because it showed me something that's obvious on the faces of it. Many of these things are obvious on the face of it. My point is, and I made this in another video, and I just got to thinking about this. Well, let's see, introduce some smoke so you can, because it was very hard. At first I started trying to hit the center of that thing. Well, I couldn't see the beam. I could kind of sort of see it sometimes, but not all the time. So I put a targeting system on there, and that's flat now. And then I put it, I'm going to pause it. Okay, now you're dealing with a globe, a curved surface, curvature. Now you have curvature, okay? So I targeted that center spot again, and of course, guess what? Well, if you understand geometry and the definition of a sphere is every point in existence that is equidistant from a center point. So that point there is flat. So when I aimed from one and hit that point, it pretty much hit over here, or 2 inches. I figured 1 would be a joke. And it was actually a little bit more accurate. But anyway, so that point there is flat. Now, so it was pretty accurate. But when you start aiming there, I think you can see the beam. If I were to start aiming there, you know, going this way. I'm going to do this from inside because you can actually maybe see it. Yeah, okay. That point is at the top of the box. Okay, that point there, you can see where it's at there, is still at the top of the box. That one there is a little bit lower. Of course, I'm not moving the laser. That one there is way up there. Okay, now, do you see the problem? Next time in a movie or a romantic scene and they're gazing out over the setting sun or the rising sun, and you're standing on a beach, watch out for video snippets of that kind of scenario, still shots, beautiful setting sun from Hawaii. From Hawaii to the place where the sun sets, if the water's still, you're looking at, I don't know, look at it on a map, you know, 6,000 miles before the sun sets. So what is the case in that point? You can do the math on it. Let's say 100 miles. 100 miles times 100 times 0.666. You're looking at, I think, I should have figured it out. 666 miles of curvature, where the ocean should be up in the air. But look at this. Look at this. This is obvious on the face of it. Tell me how a setting sun is going to go anywhere past half. Okay, it's rising. I mean, it's up in the air. Okay, let me get this up out of the way. Okay. Oh, all right. Let me move the flashlight a little bit. All right. Okay, so tell me how. Here's the sun setting. If I can get it in close enough and still hit. Okay. The sun is setting, and it's up there because it's a curved surface. It's not hitting at the angle. The angle of reflection always equals the angle of incidence. The angle of reflection equals the angle of incidence. This is simple math, simple physics. Okay? Now, as the sun is setting, let's do that. Yeah, that's a good point. Okay, on it. Stay up there. Don't bump it. All right. Sun is up in the air, and I'm going to try to hold it on one point there, okay? So there, it's up there, so it starts setting. And I'm going to try to hold the angle correct. Now it's there. You see what's happening is it's reflecting off into space, up into the air. You would not see that light at your feet, okay? It's going to get lower, yes, but you would not see it reflected touching your toes in the water at the surface of the ocean, at sea level. And as they say on a lot of YouTubes, a lot of videos, they make the point, it's called sea level for a reason, folks. Okay, at that point, now at that point I can hit straight across, yes. At that point and that is the only point at which you can see, and that's if that would only be reflecting off of one single solitary point in space on the Earth, right there. When the sun is perfectly straight across, it would hit that point and it would reflect across and touch your toes for like 1 split second. That's it. Okay. Do you see the problem that we have here with the globe Earth? Oh, and I'm tired. Take any situation, any photograph in a magazine, any scenario in a movie, disrupt the romantic setting, like I say, and say, oh, wow, that proves that the Earth is flat. Because at any point, unless the sun is really high in the sky, how is it going to hit on that side of the planet, of the globe, of the sphere? Can't happen. every beam would be shooting over. I wish I had the smoke going. Every beam would be shooting over that. It could not touch anywhere from that point on, right, all the way over here. It could not be seen, period. You have zero reflection, because at this point here, the Earth is, given a curvature, globe, sphere, whatever situation, that's the only point at which it could actually shoot across. Okay, 1 point for a split second or something, you would have a gleam of light. As it sets, this would be a good reason to have this thing filled with smoke, because from that point right there, as the sun is setting, and I've got this as, let me get the light back in there. Okay, I've got that flat. Okay, shooting the beam across. I cannot touch any point past the halfway point, past the high point, past that peak of the sphere. You cannot, in any sense of reality or any sense of common sense or any way, shape, or form, imagine, pretend, obfuscate, lie, and say that light could touch the far side of that sphere. And like I said, in the case of a setting sun from Hawaii, you're probably talking, look at the map, not that we know that it's accurate, but you're looking at about 6,000 miles. And I want to make a point. This is why, if you will watch, and I have at least 3 playlists on my How to Get Out of Babylon channel that are about high-speed time-lapse video. If a picture is worth 1,000 words, a video is worth 1,000 pictures. If a video is worth 1,000 pictures, then a high-speed video is worth 1,000 videos. And if a time-lapse video is worth 1,000 videos, then a high-speed time-lapse video is worth 1,000 high-speed videos. If that makes sense, and I've got that a little bit mixed up maybe, but you get the point. When you watch a sunset from a tall, way up in the air, a high altitude, or a place where you have a long distance, and I'm guessing probably 5,000 or 6,000 miles, you see the sun do this. It's setting, it's getting smaller, it's getting smaller and smaller, 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 smaller. And then look at a lot of them. I've looked at about 50 of them. Right at the end, you see it go, okay? Because at that point, it's so far away and it's on a curve, you can't quite see it before it gets to that point. But it does like a professional, pitcher curveball. Boom, it just zips. Why? Because it's covering so far, and it's actually on a curve at that point. It only kind of looks like a straight line up until that point, but from that point, you're seeing a curve, okay? Because it is curving around the Earth. Okay, so that's a point right there, and I'm talking like, hello, this point here from this point on, nothing, okay? So, let's put it back in flat, and I want to kind of leave this at 15 minutes just in case the Dingleberry YouTube operation that says I'm verified, I'm not on my Flat Earth channel. So let's do this. I'll just show you this real quick. I got some of these off eBay. Bang, there's a sphere. Try to make the sun go level on that, not going to happen. Totally infinite. That is an infinity of points. Well, you can mark them, but a sphere is an infinity of points that are equidistant from one central point. That's what the Earth is. From the core of the Earth, from the pinpoint core of the Earth, it's a sphere is every point in existence in the universe that is equidistant from that center point. Can't happen. You would have an infinity of points and an infinity of changes of angle, and you would not have any sunshine, sunrise, moonrise, moonset, moon setting on to your feet. Okay, all right. So I think I've proven my point there. Totally impossible. I'm going to just close this up now. This is Jerry Diamond with How to Get Out of Babylon and Flat Earth Homeland. All right. So if you're listening to this, you are the remnant. And yeah, I stole that from Terminator, but whatever. Goodbye.